Last class we discussed about series parallel combination. Now few things are there, small things that we need to study. That is power in AC circuit. Just remember this. Power P is equal to VRMS IRMS into cos phi, where cos phi is the phase angle between current and voltage. This is actually power in the AC circuit. There is derivation, but we don't need that. Just remember this one. Okay. Now, if you look into that, write down this is power, and there is another thing called as power factor. This cos phi is there, na? That cos phi is called as power factor because this phi will decide how much power will be there. It will decide, of course, RMS, VRMS, both are required for the power, but still the cos phi will decide the power. So we call it as power factor. Write down this one. Power factor. Power factor is nothing but cos phi. Okay. Now, why? Because suppose if you take pure inductive circuit, that means inductor is there, nothing else is there. In that case, although current is there and voltage also will be there definitely if you apply, but power will be zero because cos phi is zero, na? Because phi is 90. So remember this cos is a very important thing which will decide the power. We call it as power factor. Cos phi is called as power factor. Remember that. There are small things like this you need to understand. Wattless current. When power factor is zero, there will be current, there will be voltage, there will be current, but power will be zero. Check it. If phi is equal to pi by 2 or cos phi is equal to 0, then the current is called as wattless current. Few more things we need to study. I think you know average value. Just a minute. Just a minute. That's it. Nothing else is there. No? Anything else is pending. Small points will be there. We need to, yeah. Small, yeah, choke coil. What is this choke coil? Nowadays, we are using LED based lights. Tube light also LED based only. Okay. Previously, we used to have glass tube light. I think some of you know that actually. Okay. Glass tube light used to be there. In the glass tube light, there is something called as choke coil. And of course, you might have seen glass tube light and all. You saw the choke, but that's not actually choke coil. That is capacitor actually, capacitive choke. Okay, right. 1 minute. Just a minute. I'll make a diagram and I'll inform you. Now take it. Assume there is a coil. Oh, sorry. Assume there is a tube light which works at around 40 watt. Okay, 40 watt. But it cannot take 220 volt. The supply is there, no, 220 volt. It can't take 220 volt. Now what to do? We'll use a resistance, right? Because it can't take 220 volt. If it can't, then immediately we'll use a resistance. Sorry. Now observe, by connecting it to the AC, no problem, right? AC source is 220 volt, and assume the tube light can take only 100 volt. Then what we need to do? We need to decide the resistance in such a way that the remaining 120 volt drop will be here, right? Yeah, circuit is perfect. Tube light is working. But just think about how it is working. This is 100 volt. This is 120 volt. Right? And check it. Don't you think it is liberating heat? This will be liberating heat, right? And if it is a 40 watt tube light, this is 100, this is 120. Let us assume both are nearly same. What is the power of the tube light? Nearly that much of heat. That means you are keeping a heater inside the room. And remember, this tube light also only light, a little bit of heat also will be there. So lot of heat will be liberated. One thing, heat liberation is a problem, but apart from that is a loss, na? So whatever energy you are consuming, 50%, or in reality more than 50% is heat. Not an efficient way. Is there any efficient way? Yes, there is an efficient way. We can use inductor. We can use inductor called as choke coil. Okay, we can use inductor called as, it's called as choke coil. Okay. 1 minute. What is the advantage of using inductor? Just a minute, I'll tell you. There's the concept of wattless current. Just a minute. Observe this. Now, instead of using resistance and liberating a lot of heat, you can use inductor there. Okay. And source is a source. Now, how to decide what inductor must be connected? Very simple. We take VL, VR, the resultant value. Do you know a series combination? Definitely you know that, right? So source voltage 220 and tube light is required only 100 volt. What VL drop something will be there, you can calculate. The value will be VL is equal to this one. And then you can use the impedance phasor. You can develop it. Okay. So you know the resistance of this tube light and omega everything you can decide. What are the advantage of using it? What is the heat liberated in the inductor? Zero. Why? Clearly given. Power is equal to VRMS IRMS into cos phi, right? What is the phase angle between voltage and current at the inductor? 90. Cos phi, 0. Power loss is 0. So this is the advantage of using inductor over resistance. Okay, heat liberation will not be there that much. Of course, we can't have idle inductor. So because we don't have idle inductor, we can't have ideally zero power, but little bit of power, but power loss is less, very less when compared to a resistance. Resistance will give you a huge amount of heat, a lot. That's it, nothing much. Just a moment. Let us understand transformer, next topic. Transformer is a device which will use AC to increase or decrease the voltage. If you give something, maybe 20 volt you give, it become 80 volt, or 80 volt you will give, it will become 20 volt. Right. That's a basic task of transformer. Okay. Transformer works on the principle of mutual induction. That means there will be two coils. In one coil, AC current will be passing through. In the second coil, EMF will be induced. Right? The construction of transformer will be two different types. Like this, it will be. Okay. So that is, there are two types, core type and shell type. What I'm discussing here is the first one is shell type. That is, there will be a soft iron core will be there, and this is the gap here, and there will be one coil. There will be one coil like this. On top of it, another coil will be there. So two coils will be there like this. This is a transformer, and this is called as core type. Sorry, this is a shell type. This is shell type. And one more is also there. This is core type. One coil will be here, and second coil will be the other side. There are two types, but both will work on principle of mutual induction only. That means when you send current through this, it generates current through this. It generates magnetic field. This magnetic field will pass to the second coil, and due to mutual induction, EMF will be induced in the second coil. Efficiency point of view, shell type is more efficient than core type actually. But still, why this soft iron core we'll use is that it will confine the magnetic field inside. It won't leak out. That's the advantage. The core must be there. Of course, there are a lot of small points, which is CBSE points I'm telling you. That probably in mains is possible, advanced no chance. Okay. So like principle of transformer, mutual induction. Principle of transformer, mutual induction. And there are two types of transformers, step up and step down. Generally, voltage input voltage is less than output voltage, then it is step up. The other way around is nothing but step down. That is step down. Right? Both are useful really. Nowadays we are not using much, but once upon a time mobile chargers are there. Na? They are step down transformers because mobiles will be charged at 5 volt or 12 volt. But input voltage will be household voltage 220 volt. So you need to step down. That is step down transformer. Step up also will be there near power stations. The power which is generated at the power stations has to be stepped up. They step it up and take it to the very high voltage, like 11 kV, 11 kilovolt. They step up. and it will come to our near to our home at the same voltage, 11 kV like that. Near our home somewhere there will be one transformer which will step it down. If some of you are living in an apartment, around 30-40 houses are there, then electricity department will give a separate transformer for you. Need not be, sometimes even for 20 houses also they'll give separate transformer. Check it, it will be there somewhere, you might have seen. That is step down transformer. It will be from 11 kV to 220 volt. Okay. So this is the thing, nothing else. And transformer ratio will be there. Transformer ratio. So V in by V out is equal to NP by NS. What is this? P means primary, S means secondary. Generally, input will be given to primary only, right? Output will be secondary. So NP by NS. So in case of step-up transformer, number of turns in secondary will be more than number of turns in primary, and vice versa you can study. Last part, ideal transformer will have zero power loss. So I can say power input is equal to power output. Sir, what is this? Students may feel, sir, if I can take 220 volt, I can make it as 1000 volt. Don't you think I'm creating energy? You're increasing voltage, but current will not remain same. Current will decrease. Overall power remains same. In reality, having a transformer with power in equal to power out is impossible. Some losses will be there in transformer. Some losses will be there in the transformer. They are so there is something called as efficiency. Efficiency means you know very well output by input. No efficiency. So I can say like this: P in into efficiency is equal to P out. If there is a transformer efficiency 0.9, then you can use 0.9. You can deal with it. Actually, importance wise very less. But if it is given, it's given, that's it. No, a transformer has a lot of losses, different ways it can lose. First thing is copper loss. What is copper loss? The wire that you are using will have some resistance, right? It will liberate some energy. Next thing is eddy current loss. So there will be EMF induced inside the core that will cause the power to lose. That's also there. There's eddy current loss. To eliminate eddy current loss, we use laminated core. Anyway, next thing is hysteresis loss. And that means what? In a one complete cycle, technically you are magnetizing core and demagnetizing. So every time when you magnetize and demagnetize, some heat will be liberated. That's called as eddy current loss. Sorry, hysteresis loss. And some flux leakage. That means primary coil, whatever flux is there, completely not going to secondary coil. Some loss will be there. And then humming loss will be there because when alternating current is passing through, the transformer size very minimal will decrease and increase. It generates one humming sound. That's why it's called as humming noise. These are the basic idea of transformer. Probability is very low in mains. If it is given, maybe you are lucky or unlucky because some students won't study. They're unlucky. If you study, you are lucky because what we can say, logically speaking, it's not too tough. It's very easy. It's very easy to deal with. That's why. Okay. That's it. AC generator you can study on your own because AC generator up to now, not much of questions in mains or advanced. Advanced and cell, mains also less. We'll discuss about a small topic, very small topic called as EM waves. Before going to EM waves, you need to uh, remember this part. That is induced electric field. Sir, what is that induced electric field? When we discussed EMI, I think you remember that at the end of EMI, we discussed that when magnetic field is changing, it will cause electric field around it, right? Changing magnetic field will create electric field. Concept is there, right? I think I discussed it. We solved some problems also based on it. Like this. Like this it is there, check it. Of course, in reality, both will superimpose like this, but diagram will be little irritating. That's why I made it separately. The changing magnetic field, time varying magnetic field it will be. So one thing we need to understand. So changing magnetic field will create electric field. So dB by dt will give you electric field E. Okay. How it will give formulas and all these things are there with us, but changing magnetic field will give you electric field. Right? Keep it aside. Let us go for the next discussion. That is Maxwell's equations. So what Maxwell did is that simply he wrote four equations of uh, current, electricity and magnetism. And remember, he haven't discovered any one out of four. He discovered nothing. Okay. And he wrote on a paper and submitted, and they started calling them as Maxwell's equations. Surprising, sir, he haven't discovered anything. No. But because he wrote on a paper, submitted to the university, and they called as Maxwell's equation, then I can submit all the rules of physics and will they call with my name? No. He has a great contribution for what? That electromagnetic waves and linking electricity and magnetism. Before going to that, we need to understand that what he did exactly. So what he did is that very simple. First thing, he took the basic laws of electricity and magnetism. Basic laws connecting electricity and magnetism. Okay. So let us discuss about those laws first. Okay. First one is Gauss law. Gauss law. This is a part of Maxwell's equations. Gauss law. In electrostatics, integral E bar dot dA is equal to Q in by epsilon naught. This is Gauss law in electrostatics. After that, one more is also there. Gauss law in magnetism. Integral E B. B dot dA is equal to 0. Why? Because magnetic monopole doesn't exist. And any loop you take it. You take any loop. Closed loop. So net flux will be all closed loop, closed surface. Definitely net flux must be 0. I think I discussed this one already. This is Gauss law in this is Gauss law in electrostatics. 1 minute. This is Gauss law in electrostatics. This is Gauss law in magnetism. After that, 1 minute. After that, we have EMI. Faraday's law is there, right? Faraday's law. Let us take that one. Integral. Actually, E is equal to d phi E by dt, d phi B. That means whenever magnetic flux changed in a circuit, EMF will be induced. We can write like this. This is nothing wrong. It is much more precise if you write with minus sign. And instead of EMF, integral E dot dl is much more preferable. Integral E dot dl is much more preferable in a closed loop. This is okay. Up to this is fine. But one more thing is also there. That is Ampere's law. Integral B dot dl, integral B dot dl is equal to mu naught times In. These are the four things that we need to understand. And these four things are called as Maxwell's laws. But what Maxwell did, observe carefully, he found a flaw in this. Sir, what is the flaw? Okay, let us understand the logic here. Suppose if you take a wire like this, if you take a wire, and if you take a Amperian loop like this, just a minute. Yeah. If you take an Amperian loop, let us make it as a dotted line so that it is, you will not feel it's a wire or something. Amperian, if I take it. Now, if you want to use B dot dl, definitely you can use, 1 minute. B dot dl is equal to integral mu naught times I in. How do you decide I in? Sir, this current is I in only, sir. Yes. Suppose if I take it like this is not I in. This is not I in. This current is not in. This current is out. Common sense is fine. You can definitely, but what is the idea? What I'm telling you is that if you want to get the I in, simply imagine a membrane here. That means soap film like that. Take the Amperian loop, dip it in soap film, and there will be a film formed. And if current is piercing it, then you can take it as I in. If current is not piercing it, then it's not I in. Then next little bit logic. Is it necessary the film must be flat? No, because Amperian loop need not be two-dimensional. Amperian loop can be in a random shape. So when Amperian loop can be random shape, the film can be in random shape. It doesn't matter? No, it doesn't matter. Okay. Then let us have a different approach here. Let us have a little different approach. The film, let us take it like this. The film, flat film is one case. Another, I'll take a one different shape like this. Different shape film I'll take. If I take film like this, surface, okay? Then also it is valid, yes. Observe carefully. If you take flat film, this current is piercing. Curved film also current will be piercing. Whatever current piercing the flat film definitely will pierce the curved film also. Now see, some students or some people will try to find errors. That's a good thing actually, if you can find proper error. The error is like this. Suppose you have a current like this and it is coming back like this. Understood? Now check it. There is a problem for the surface. Okay. Now observe. If I take the flat surface here, current is passing through, and in the curved surface, current is not passing through. No problem at all. Why? See, if you take the case of curved surface, current is coming in, going out, but nothing is piercing the surface. So I in is 0. But if you take flat surface, current comes in, goes out. If you take flat surface, current comes in and goes out. So in is positive, out is negative, net is 0. In any way, it will be same. So it is independent of surface. This is the point Maxwell thought. Okay. Why this flat surface and curved surface gives same answer? Because current is coming in, must go out. Like this or like this, somehow it go out. But is there any place where current comes in but doesn't go out? Huh? How come, sir? This is the crux of the point if you want to understand. If you want to memorize, you don't need to worry much about it. Current comes in and doesn't goes out. Is it possible? Do you know any area, any place where current comes in but doesn't go out? Not possible, sir, because if current comes in, doesn't goes out, what happens? Tell me. Anyone can tell?
So,
Current comes. What? Tell me.
the charge gets accumulated on.
Okay. So in our studies, there is no place where charge gets accumulated.
Sir, there is in parallel plate capacitor.
Yes, that's what. Exactly the same thing Maxwell took. Maxwell took the capacitor. Okay. And then he thought like this, yes, there is a place, capacitor. In the capacitor, current comes in but doesn't goes out. Right? That's the thing exactly. So I'm taking current comes in, goes out, right? So this is capacitor, resistance R, switch S, some source E is there. Now focus on this. I need a bigger diagram, but it's okay. I'll zoom in, no issues. If I take an Amperian loop like this, then observe while charging, not always. While charging, if I take the surface like this current I is piercing the surface. So definitely current is passing through. But if I take this surface like hemispherical bowl kind of thing, if I take it and there is no current passing through, right? That's the point where Maxwell found a flaw, right? If I take surface as a curved surface, it says integral B dot dl is 0 because I is 0. If I take flat surface, B dot dl is not 0. Remember, for both surfaces are for same Amperian loop. It is not possible, no? Then he introduced a thing called as displacement current. Integral B dot dl is equal to mu naught times In. Apart from that, he says mu naught times I d. In means you take conventional current. IC, let us call conventional current. He created a new term called as the displacement current. Once you take this, everything will be perfectly fit in. Everything will be perfectly fits in. Understood? Good. Okay, sir. How? What is the displacement current? So ID, displacement current is equal to epsilon naught d phi E by dt. Epsilon naught d phi E by dt. What is phi E? Electric flux. D phi E by dt is what? Tell me, change in electric flux. He says that changing electric field also as good as current. Sir, I'm not getting it. We'll do one thing. I'll prove this one. If you're interested, listen to me. Otherwise, this part is not required. Proof is not required for IIT JEE. Okay, but I'll prove it. Now observe, capacitor is there. Capacitor is C. C formula you know very well. Epsilon naught A by D. This is the capacitance formula. Let us take parallel plate capacitor. Then charge on the capacitor is Q. Electric field between the plates of a capacitor is sigma by epsilon naught. You know very well, sigma by 2 epsilon into 2. That is nothing but Q by A epsilon naught electric field. Electric field between the plate of a capacitor is this one. Okay. Now, electric flux phi is equal to field into area, right or wrong? E dot A. Let us take everything is normal. EA cos theta, but cos 0 equal to 1. So it will be Q by A epsilon naught into A. This is phi. Right? Okay, fine. Finally, I'll calculate d phi by dt. More perfectly, we have to write phi E because flux means right now electric flux is also there, magnetic flux also there. So we need to. So observe here, AA gets cancelled. AA gets cancelled. Then it will be what? Tell me. Okay. D by dt of Q by epsilon naught. If I take epsilon naught out, d by dt of Q. That means what? The rate of change of electric flux between the plates of a capacitor is nothing but 1 by epsilon naught times rate of change of charge. So what is rate of change of charge? What rate charge is changing? That's nothing but current, na? dq by dt is current, right? Current coming into the capacitor. So that's nothing but what? Tell me, I. So you can write it as 1 by epsilon naught I in the wire, right? Now put this value here, you'll understand. I displacement is equal to epsilon naught into 1 by epsilon naught I. Cancel. So if you take this membrane, conventional current is 0, but displacement current will be there because electric field is changing. And if you calculate, you get same answer, because if you take flat surface, displacement current is not there, conventional current is I. If you take curved surface, conventional current is not there, displacement current is what? Again same I, check it. So this is the derivation. If you remember good, otherwise just leave it. But what's my point is that, suppose you take a capacitor, I'm enlarging it, right? Large side. Okay, take a capacitor, and between the plates of a capacitor, electric field will be there, right? Okay. Now, if you observe closely, just a minute, yeah. If you observe closely, if I make an Amperian loop here, if you make an Amperian loop, there is no current passing through, but displacement current is there. If you study a little bit deep about displacement current, okay, you will understand this logic. Why magnetic field is created here? That's the question. Why magnetic field is created? Displacement current is there. Focus here. Focus. Why magnetic field is created? Displacement current is there. What is the displacement current? Yeah. Displacement current is nothing but epsilon naught times d phi e by dt, right? Epsilon naught times d phi e by dt. Okay. This magnetic field is created because of change in electric flux, right? Check it what we discussed at the beginning. Changing magnetic field will create electric field. Here, changing electric field is creating magnetic field. Check it. That's why Maxwell's and the equations are so famous. He understood that d phi e by dt, change in electric flux will cause magnetic field, and change in magnetic flux will cause electric field. That means change in one will cause other. He doesn't stop there. He continued. Okay. Previously, we used to think like this. To create magnetic field, we need a bar magnet or current carrying conductor. To create electric field, we need a charge, right? But now we can create electric field without having charge. Change in magnetic field is sufficient. Sir, at least to create this magnetic field, you need a bar magnet, na? No. You can create magnetic field by changing electric field. So, can they be self-sufficient? That means change in electric creates magnetic, and change in magnetic creates electric in between them. So, you are creating electric and magnetic fields without having a bar magnet, without having current carrying conductor, without having charge. Nothing is there, but electric and magnetic fields are there. Is it possible? Yes, it is possible. That is nothing but electromagnetic wave. That is nothing but electromagnetic wave. And he used these logics, whatever we developed it, and further he developed, and he proved that electromagnetic wave, okay, electromagnetic wave exists, and completely he used all, what we can say, only electricity and magnetism, only loss of electricity and magnetism, and only what? Just a minute. Variables also, only electricity variables and magnetic variables they used. And he discovered something about electromagnetic wave, and which is really surprising. And I will give you the formulas, then you will understand. If you observe physics, you feel really really surprising. Okay, 1 minute. Just a minute. Now, electromagnetic wave will be like this. Let us take electric field as what? Red color, magnetic field as blue. Exact diagram I can't make because it is three-dimensional, but diagram will look like this. Observe. This is electric field E, this magnetic field B. Importance wise, instead of eddy currents, instead of transformer, electromagnetic waves are more important. Definitely it is important. So remembering the formulas are very important. Bro, continue. We can write electric field E as E naught sine omega t minus kx. Okay, Ey you can take. Then Bz is equal to B naught sine omega t minus kx. Actually, as a teacher, I may miss 1 or 2 points here, but if students are there to ask right questions, anyway, teacher won't miss it. But I'll try my level best to give all the points. First and foremost point, will there be in phase? Will they means what? Electric and magnetic field. Be in phase, always be in phase. That means this omega t minus kx, this omega t minus kx, it must be always same. Is there any possibility that electric field may be a little lagging in phase or like this? Never possible. Never they lag. Will they be phase? Always. No doubt about it, they must be in phase. Is there any other rules? Many are there. First thing, E and B are perpendicular to each other and perpendicular to velocity. Don't think like this. B is perpendicular to velocity. E also perpendicular to velocity. Check it. Electric field is vibrating along y-axis. Propagation is on x-axis. Magnetic field vibrating along z-axis. That's the case. First thing. Then E by B equal to C. That means at any given point, you take any point, E value you take it, B value you take it. The ratio of E by B must be C, or you can say V also, because the electromagnetic wave need not be in vacuum. It can be some other place. It can be some other place. Any medium you take it. It is velocity of that medium you can take. Okay. Or V. Okay. That's it. No. Observe in terms of direction, E cross B, B must be V. E cross B. Cap means what? Direction only we have to take. Electric field you take it. Magnetic field you take it. If you take cross product, E cross B will be like this. Na? That will be the direction of this one. So that does means if the wave is traveling in negative x-axis, then B must be on the other way, like this, or E must be on the other way, right? Next, that's it. No, this is the thing surprising, really surprising. Velocity of wave, or we will take light, is equal to 1 by square root of mu naught epsilon naught. Observe these things. This is, I personally feel really surprising it is. Mu naught is completely magnetism property. Epsilon naught is completely electric property. By combining them, we are getting into optics, right? So, mu naught by 4 pi is equal to what? Tell me. 10 power minus 7, right?
Minus 7.
1 by 4 pi epsilon naught is equal to 9 into 10 power 9.
Power 9.
Now observe, if you take mu naught, it will be 4 pi into 10 power minus 7. And if you take epsilon naught, just a minute, it will be 1 by 4 pi into 9 into 10 power 9. What is mu naught epsilon product? If you take the product, will be this multiply with this. These two gets cancelled, and this is mu naught epsilon naught. If I take square root of it, simply I can write like this. And 1 by mu naught epsilon naught, if I take it, it will be, you have to take reciprocal. 9 into 10 power 9 by what? 10 power minus 7 under root. So 10 power minus 7 go to numerator. It will be 10 power plus 7. How much it is? 9 into 10 power minus 6, minus 16 plus 16 under root. So it is 3 into 10 power 8. Completely two different chapters. We don't find any link over there, but he linked it. Maxwell linked it. And he proved mathematically it's a transverse wave. And it is transverse anyway, it's not. And polarization is there. One topic, we'll discuss that. That proves is a transverse wave. Everything he proved. And he haven't used anything from optics. No law from optics. Everything is electricity and magnetism. He gave a proof that light is an electromagnetic wave. And actually speaking, he created a, what we can say, pattern that, many scientists are really obsessed with. He combined electricity and magnetism. Then after that, many scientists are thinking, why can't we join gravity and electrostatics or something like that? Grand unification theory. Even Albert Einstein also thought of combining them. But anyway, is not able to. Still, we are not able to. Anyway, let us continue. This is the formula. Sir, you can write like this. V is equal to 1 by square root of mu epsilon. Or you can write mu as, this is a derivation not required, but just final answer is required. This can be written as mu r mu naught, epsilon r epsilon naught. So root of mu naught epsilon naught is what? Tell me, C, right? So V is equal to C by square root of mu r epsilon r. Okay. Do you know what is mu r epsilon r?
Relative.
Mu r, that's okay. Relative is C by V, right? Do you know what is C by V? Refractive index.
Sir.
Refractive index. Got it. Refractive index of the material. Like that, many points are there, too many. You need to understand the points and all. Another problem is there with this. Actually, I observed many teachers when they make the question. Velocity of light they take, you can take velocity of light from the wave equation also. V is equal to omega by k, right? Now, a teacher who's creating a question has to be careful about many points here. Why? I'll tell you. Just a minute. Yeah. Many points he has to be careful. That is, the values that they give here will give velocity. That velocity must match with E by B also. Next thing, when they write kx, what's the meaning of it? It is traveling along x-axis. That means E cross B must be positive x. Like that, multiple points are there that examiner has to remember. Anyway, let me write all the formulas required in this segment. That is ID, displacement current, is equal to epsilon naught d phi E by dt. Epsilon naught d phi E by dt. Right? So I think will they be in phase? I don't want to write like this. I'll write E and B always in phase. E and B always in phase. Remember this. Okay. E and B will be always in phase. Electric field formula, magnetic field formula, all these three are perpendicular to each other. E by B is equal to V, correct. The direction will be like this. Then what? Relation. Good. Next, write down. Actually, I'm going out of this topic. Energy density in electric field. Energy density in electric field will be half epsilon naught E square. Energy density in magnetic field will be equal to half B square by mu naught. B square by mu naught. But try to understand, we can't use these formula directly here because electric field is not uniform, it is increasing and decreasing. We need to do integration. Right now, I won't do that. Average energy in electric field in electromagnetic wave will be 1 by 4 epsilon naught E square. E square, E naught square. What is E naught? The peak value. Similarly, average energy in magnetic field is equal to 1 by 4 epsilon naught B naught square. And final point I would like to tell you that is energy associated with electric field and magnetic field, both must be same. So average energy in the electromagnetic wave will be, you can write like this. Sum of these two you can write, but you know very well that this equal to this. I can prove it, but still, you take it for granted. Both are equal. So I can replace this with half epsilon naught E square, 1 by 4. So that can be written as 1 by 2 epsilon naught E naught square. Remember, this is E. This is used in any place of electrostatics. Okay. So example, if you take parallel plate capacitor, there E will be there. By calculating electric field and multiplying, you will get energy density. Energy by volume. If you multiply with volume, you get what? Tell me. Energy. Clear? You will get energy. You can get that. So you'll get little confused. 1 by 4, 1 by 2, little confused. Be careful. So in a nutshell, of course, you can write this one like half B naught square by mu naught also you can take. You can take like this also. Okay. Almost all the required formulas of electromagnetic waves are there in this.